Alright, and we're back. I just got the frustrating experience of recording for like 10 minutes and then noticing I didn't have the record button running. So, the problem what we're going to do next is in fact not the problem that you were just seeing on the piece of paper for the past bit, because I've decided I want to do a different one. I'll change it before it gets posted to Canvas. Let's let x be a subset of the real line. Let's assume x intersect negative n to n is countable for all n in n. And let's prove that x is countable. Well, there's one thing that you want to prove something's countable. So what are the strategies we have to do that? So how would you do that? I guess we have a few paths. We could find a bijection from n to x. But we've seen that we don't need all that. The other strategy we could use is we could just find a surjection from n to x, or an injection from x to n. In fact, those n's don't have to be n's. Those n's could be anything countable. Alright, we proved that. But we also proved other things. We proved that if x is a union of a bunch of countable things, then it's countable. But wait. There are only countably many natural numbers. So for each set of natural numbers, this set's countable. If I let the n get really, really, really big by unioning over all choices of n, well, that'll hit all of x. So let's use that. Well, x is thought to be the same as the union from n equals 1 to infinity of x intersect negative n to n. And we could compose a double set containment argument for that, but I don't think I want to. By assumption, x intersect negative n to n is countable. So that's something. But then x equal to the union from n equals 1 to infinity of x intersect negative n to n is a countable union, because that union only runs through natural numbers, so I'm only unioning up countably many things, of countable sets and so x is countable. Oh, neato. There's a proof. Cool. So what's the point here? If you remember all the properties that we've proven about countable things, then you can use those properties. And if you do, sometimes you can get away without having to find any sort of bijections or surjections or whatever. Neato. See you in the next one, which will be topology.